Hello, geometries. Mr. Rising here once again. This is chapter 11, the start of a new chapter, and this is a big one because this is the world we live in. This is the three-dimensional world, length, width, height, throw in a fourth dimension, time, and you start to figure out that all these things we've been learning and building towards are helping us understand and plan and design what we're going to do in our world. I don't know if any of you have been to Chicago, but this is the Great Bean. It's a very cool three-dimensional object, and if you ever get to Chicago, check it out. It's just a very cool experience to get next to. The first part of this assignment, and you can even stop the video now and go do this. This is an assignment you have to turn in. It's all about drawing. So when you work with three-dimensional figures and trying to convey information to other people, having the basic skills of drawing a three-dimensional figure is pretty important. Whether you care about art or not, but even when you're trying to make a drawing, if you're working on a car, trying to put things in position, in perspective is really important. Now, I'm not anticipating you're going to be doing great artwork like this, although some of you will be. So maybe if you want, go ahead and pause the video and go do your 3 drawings and answer the questions. And you can submit that on Canvas. If you want to keep going, here's the basic idea. Solids are three-dimensional figures. They can have flat or curved surfaces, right? Each flat surface is called a face. It's like a sheet of paper, a face. An edge is where the segment where the 2 faces come together. So again, we're looking at something like this. And a vertex is a point where 3 or more faces intersect. In a cone, it's the point. All right? Now, other key I'll try not to say all right or right 20 times in this video. When you look at solids, prisms and pyramids are named by the shape of their base. So for example, a triangular prism basically has a base on the bottom and top that are triangles and kind of rectangles on the sides. Same thing with a rectangular prism or a square prism, right? Pyramids, of course, come together at a single point. Cylinders have circles as bases. And basically, if you unwrapped the cylinder, it would be a rectangle. And of course, a cone has a circular base, and it comes together at a point. Just remember here, with a cylinder or a cone, you don't have edges, which is kind of an interesting way of looking at it. That's really the first part of the lesson. All right. So again, it's going to say classify each figure. So in this one, name the vertices, edges, and bases. So this first one is a triangular pyramid. And its vertices, right? Our vertices are R, S, T, Q. Edges would be like Q, T, Q, S, S, T. Of course, and they would continue on. I mean, there's a lot of edges on some of these figures. The base, of course, the base would be Q, S, T. Now, let's jump over here to the cylinder. Okay, it's a cylinder. Good. It's got a circular base on top and the bottom. Name the vertices. There are none. Name the edges. There are none. And of course, the bases would be, so it's a cylinder. Bases would be circle. Again, that's the symbol for circle A and circle B. If you want to try the next 2, I'll show you the answers at the on the next slide, or in a couple slides. Now, this part is really important depending on what performance assessment you're going to do. Now, you've been in my room all year and you've been seeing these nets. It's a net design all over the room. So this is one way that you can demonstrate understanding. So pay close attention if you like this kind of hands-on artsy project. A net, of course, is a diagram of the surfaces of a three-dimensional figure, right? So you're building something in 2D that you can bend and fold into 3D. A net at the right is a rectangular face with 3 triangles, so it's going to form a rectangular pyramid, right? The other thing, I said right again. Dang it! Right meaning straight up and down. A right regular pyramid would go straight up and down. one that's slanted or oblique would be tilted off to the side, and I'll show you that at the very end. What I wanted to include here is if you are going to put dimensions on these, would be the time to do it. So maybe this is really a 4 centimeter and this is an 8 centimeter, and then you can figure out, what this length would have to be. This is where you can actually label everything or measure it out and then put it together. Finally, the other big concept here in the first section of chapter 11 is a cross section, and that is where a plane intersects a three-dimensional figure. It does not always have to be horizontal or vertical. It can be at a diagonal. It can do some really cool things. And if I had all of you in class, I would take a stick of butter. In fact, if you're just feeling a little fun, get a stick of butter, which is a square prism, and let it get to room temperature. So it'll be soft, but it won't be runny. And you can take a knife and you can slice. You can slice it in different ways. See if you can slice me a hexagonal cross-section from a stick of butter. It's really cool. All right, I got a little joke for you. What is the angriest part of a 3D figure? That's right, it's its cross-section. I move on. In these, you're working with nets and cross-section. So again, the first one here, oh wait, it looks like a box. It looks like a cardboard box. Well, that would be a rectangular prism. This one would be a triangular pyramid. This cross-section, if you look at it, if you took a cylinder and you sliced it vertically, right, you would end up with a rectangle. This cone, if you sliced it like that, vertically, you would end up with a circle. Now again, you can think about different ways to slice these objects. And Khan Academy is a great place to practice this too, and it helps build your mastery. Here's the solutions if you're curious about anything else. You were practicing any of these other problems. The last thing I want to go over when we talk about prisms and cylinders is the difference between height and slant height, or right and oblique. So for example, I'm drawing a pyramid, in case you can tell. And you'll notice, and you're going to do this or you've already done it, the dotted line adds depth and perspective. The idea is you couldn't normally see it unless, it was a see-through object, right? You couldn't see the backside of the pyramid because the fronts would be blocking it. So first of all, the height of this object has to be perpendicular to the base. So watch, I'm going to put it in here right now. So that is the true height of the object. The slant height is the length along one of the sides. So that would be right here, and I'll do it in purple. My board's just a little bit off. And you can see this is the slant height. If you took the side of a figure, right, of course it is longer, like the side of a roof. The height of your house is perpendicular. The length of the height of the side of the roof is different. And so that's a big thing, because when you see that term slant height, that's what it's referring to. I think I made this video long enough. Maybe just one last thing. Right prisms and cylinders are basically straight up and down. Oblique means they might be tilted over. So it might look something goofy like that where it's tilted off to the side. But again, there, the height would be this one. And then the slant height would be that part right there. All right, let me know if you have questions. I hope that was helpful.